Hello everyone, how have you been? I just got back from Italy and it was great, but it is also great to be back here at home in London for another late night session of The Power of Reason. And a special session because, well, this is the 10th and final episode of this series, but also because today we are going to capitalize on a bit of everything that we learned so far in this series. And we will try and develop a new skill, which I call the super forecasting skill. That means being able to make better predictions of the future and in turn guide our present judgment. But as always, before we jump into it, let's take a few steps back and look at how we define what probability is, because there are two main interpretations. First, when we talk about probability, this could be interpreted as the frequency of an outcome when the action is repeated many times. For example, if I toss a coin only 3 times, I will not be too surprised if I get tails all 3 times. But if I toss it an infinite number of times, I will get tails 50% of the times, which means that the probability of getting tails is 50%. So here, like I said, probability is the frequency of an outcome when repeating an action several times. There is also another interpretation of probability, which is the degree of credence we assign to something. For example, if I'm about to toss a coin, I can say that the likelihood of it coming out tails is 50%. That is the level of credence I assign to the outcome tails, 50%. Why is it useful to have this different definition? Well, under this different interpretation of probability, we can assign credence or degrees of belief to future events, which will happen only once. For example, I could say that the Los Angeles Lakers have a 70% chance of winning the next game. Clearly, we cannot repeat the game an infinite number of times, like we do with the coin toss, to see if it's true that 70% of the times the Lakers will win. Instead, the probability is assigned based on prior knowledge. For example, how often the Lakers have been winning this season, and then updated as new evidence arises. For example, is the team in good shape today? This is called a Bayesian approach, as opposed to a frequentist approach, in which probability can only be measured for events that can be repeated many times. So the Bayesian approach is for events that only happen once. And it takes its name from Reverend Thomas Bayes, a priest and a mathematician of the 18th century. And it is what we already used in the last episode to include Bayes rates or prior beliefs in our judgments. Even if I didn't mention Bayes last time, we've been using Bayes' formula. As we have seen in previous episodes, our intuitive mind has the tendency to use only the situational evidence and to ignore the Bayes rates because we think by representativeness or availability. And we have also seen that including Bayes rates improves accuracy. Let me recap 2 examples quickly for you. Remember Adam in the rural village? We said that if I'm 90% confident that this description of Adam as meek and tidy with a passion for poetry better describes a librarian than a farmer, I still need to consider the prior knowledge that in the rural village there are so many more farmers than librarians. So Adam is actually more likely to be a farmer. This is the example I made last time. Another example, very similar, was the breathalyzer example. If a breathalyzer gives false positives 5% of the time, but only 0.1% of drivers out there are actually drunk, Bayes' theorem shows that a driver picked at random who tests positive only has a 2% probability of actually being drunk. which is counterintuitive result, but we've seen that is correct. We can adapt a similar model to making more reasonable judgments using Bayes rates and situational evidence. As always, we need to resort to an example to better understand this. Our protagonist this time is a girl named Anna. If Anna was able to read and write at the precocious age of 4, what is her grade in English in high school going to be? Most probably. There's a question for you. What do you think? Well, I think it's tempting to say that she most probably will have an A in English because she could read at 4, so she's smart. However, there are so many other factors that influence how well one does in school, and her precociousness probably has a smaller influence on that. A better estimate would be made by taking a Bayes rate. For example, what is the average English grade at her school? Which could be B. And then integrate the situational evidence. We know that she was precocious, so probably academically talented. By adjusting from the Bayes rate, we go up. So perhaps B+ is a better estimate of her grade, rather than going straight for A. This is a bit counterintuitive because our mind likes to think by representativeness, but we have seen how that can fail when we think about probabilities. A similar method of using Bayes rates and then adjusting up and down based on situational evidence is what can give us better prediction of future events, such as socioeconomic and political events in the time frame up to 1 year ahead. These events depend on several factors and complex interactions, of which no one can possibly have complete knowledge or foresight. So the predictions are expressed not in certainties, but in probabilities. The way meteorologists do it, when they say there is a 90% chance of rain. In order to make a reasonable forecast, one should not fall for the availability bias, which, as we've seen, makes things we can remember more easily, such as a recent tragedy, for example, that we've seen on the news. We feel that that's more probable than it actually is. It is also important not to think by representativeness, because that leads us to focus only on the situational evidence or on the most recent evidence. It is important to use prior knowledge of similar events and then adjust based on new evidence. And we give a degree of belief expressed with the probability estimate. So this is the definition of probability as a degree of belief. I want to emphasize the importance of giving a precise value to our credence, rather than just express a prediction using vague verbiage, such as it might happen, or there is a distinct possibility. And also avoiding overconfidence, such as saying, for sure it's going to happen, or not a chance. I'll go into the reasons for this very soon. But let's start with an example first. In 2016, I'm sure many of you remember, most experts were giving Donald Trump a 15% chance of winning, while Nate Silver of 538 gave him a 30% chance. So double what everyone else was predicting. How did he get a more accurate forecast? While everyone else was focusing only on the results of the polls, Nate Silver included prior knowledge by taking into account poll historical accuracy. He noticed that there was up to a 2% error in past poll estimates. While this seems small, the polls were favoring Hillary Clinton by a percentage smaller than the poll error. Including this mathematically in the forecast gave Trump a much higher probability of winning. Now, a common criticism to this prediction would be that Nate Silver gave Trump a 30% chance of winning, so a 70% chance of losing, but Trump won. So the prediction was not that good after all. This conclusion is actually not logical, because the probability we assign to a future event, which will occur only once, is only our degree of credence in the event happening, just like for weather forecasts. If a well-calibrated forecaster who makes hundreds of predictions a year gives a 70% probability to an event, it means that 70% of the times the event will actually happen, but also that 30% of the times it won't. The accuracy of the forecaster cannot be tested by taking one individual case, but in a cumulative way, by looking at the track record of the forecaster. So, how many times do they get it right? And if it matches with their predictions. In a 20-year study, Philip Tetlock measured the accuracy of the predictions of many pundits, analysts, columnists, academics, and public experts, and found that on average, the predictions were no better than chance guesses, so 50-50, or like he put it, not better than a dart-throwing chimp. The accuracy of forecasters is measured by asking them specific rather than generic questions. So instead of asking, is the Syrian regime stable? A more specific question can be asked, such as, will Bashar al-Assad remain president of Syria through 2020? This type of specific question makes it more obvious if someone is good at forecasting or not, because it can be tested directly. A good way to make this prediction should be not to only look at the situational evidence, for example, what is happening in Syria right now, but also at the base rate information. And an example of this could be that autocratic regimes tend to last many years, until the death of the dictator very often. So that reduces the likelihood of this particular regime to be near its end, despite possible unrests in Syria that can be observed in recent time. The most interesting result of the 20-year study was that there are some people who are consistently better at making predictions. Not only better than pundits and experts, but also 30% better than professional intelligence officers who have access to classified information. Good forecasters are open-minded, and they frequently change their mind. They avoid seeing non-existing patterns in the fluctuations of randomness, which our mind tends to do. We've seen this in previous example of false causality. We like to find patterns in randomness and in things that are due only to chance, or effects like the regression to the mean. Super forecasters are also not attached to personal theories or political allegiance, and they do not overcompensate for mistakes. A classic example of overcompensating for mistake in a prediction is the way American intelligence or American intelligence professionals overcompensated for the missed prediction of 9/11 with the wrong prediction of the weapons of mass destruction in Iraq. Of course, their attitude is understandable, because in the eyes of the public, the worst thing an official can do is the same mistake again. So very often they end up doing the opposite mistake instead of a probability-based decision. And similarly, most of the renowned pundits of today, whether left or right, make predictions using vague verbiage to maintain the reputation in this blame game society that we live in today. If I say that there is a distinct possibility that, say, Donald Trump will do something, and in the end he does it, I can say, see, I told you. And if he doesn't, I can say, well, I only said it was possible. And this will spare me in the blame game. Of course, this is of no use to anyone other than to get attention to myself. Unfortunately, this is what most public experts and pundits do when they use this vague verbiage and then they say, I told you, or I only said it's possible. No use of anyone other than getting attention. But they do not make a definitive probability judgment. And this is mainly because if they say something more specific and then they're wrong, they will be ridiculed. This is the times we live in now. So here is a wild idea that I like to throw out there. Instead of incentivizing rhetorical ridicule, we should incentivize thoughtful probability judgment. At least if the real goal that we have is actually the pursuit of truth and of learning something, instead of the political posturing and the ideological kabuki dances, like Tetlow calls them, which are so common in the media nowadays. Even on a smaller scale, making better predictions can be useful in everyday life. If you're embarking on a complex project, such as, writing a book or launching a startup, writing the first chapter of the book might come easy and make it rather difficult to predict obstacles along the way. You feel, okay, this first chapter was easy, I'm going to finish this book very soon. And to this, you may add that, as we know, our mind likes to create a coherent story, even with information we don't have. So it is difficult, after all, to think what we do not know. We might think that the book will be done in a few months, but are we right? What else could we do? Perhaps we could consult others who have written books on the same subject. If on average they all took 5 years to finish their book, then an estimate of a few months is too optimistic. So we start from the baseline of 5 years, and then we adjust up and down based on our confidence. And we'll have a more accurate prediction of how long it will take us to complete this book. Of course, then it's difficult to interiorize this prediction, even if you make it. And in most cases, we will forget about it. And this is what happens to most startups. On average, 70% of startups fail before their 10th year. So this is an interesting statistic. And this constitutes the base rate that we can work with. Precisely because most entrepreneurs ignore this base rate, they will start a business, making predictions based on the situational evidence at hand without integrating it with the prior knowledge or the base rate. If you are a very confident entrepreneur and think that 70% chance of failure does not apply to your business, well, maybe you might give it only a 20% chance of failure. Even with this confidence, adjusting with Bayes' theorem, you get a 40% chance of failure because your baseline is not 50%, but 70%. Even with a mathematical understanding of this, it is difficult to then act accordingly because our intuitions and gut feelings end up taking over. And this is not necessarily a bad thing, by the way, because starting a business, which could be a learning experience nonetheless, and with taking risk, that comes the potential upside. And in fact, our economy relies on all businesses to start at some point. So in conclusion of all that has been said, every one of us can be better informed and have a better understanding of the world by being more critical and open-minded and less politically attached, by observing our cognitive fallacies and not trusting our instinct impulsively, and also by having a certain degree of mathematical numeracy. Right, so congratulations to everybody, because you have made it to the end of this episode and of this series. A bit sad, but a bit exciting as well, because I feel we have accomplished something. I hope it provided some insight and inspiration for all your thoughts and, of course, further research. Don't just take my word for it. This is just to provoke your thought. I would like to end things actually on a positive note. As individuals, we are all prone to biases and logical fallacies, as we've seen in this series. But it does not mean that we are irrational. Humans have discovered these logical fallacies precisely because we are capable of rational thinking. And we can define a baseline of rationality against which we can measure irrationality. Humanity has amassed so much knowledge, and we have created science and institutions which are tested against reality, and they do work, and they help us successfully navigate an ever increasingly complex world. By looking through the lens of reason, we can see the progress of humanity. It is enough to look at the data and the long-term positive trends without falling prey of irrational fears and pessimism. And we need to believe in the future of innovation while fostering constructive debate, tolerance, and pluralism. Right. Now, thank you for real, and I will see you soon. Bye-bye.